Now, about statistics, the first thing I want you to remember is that we've been dealing thus far with statistics all along in Oracle Database Performance Tuning. However, when we discuss the Automatic Workload Repository, or AWR, those are performance-related statistics, aren't they? Here we're turning our attention more to classical relational database theory. Remember, we use the structured query language, or SQL or SQL, however you want to pronounce it, to do our data access. As you may also know, the structured query language is not an imperative programming language where you can, like with C# or Java, you create your code and explicitly define how you want the code to work. Instead, SQL is what's called a declarative language, where we ask questions of our data, we give commands to Oracle, but we're not concerned with specifically how Oracle is carrying out those commands. That's the main difference between a declarative and an imperative programming language. Now, I say we don't care how Oracle fulfills those queries. That's not true exactly. As a matter of fact, this whole module is about caring about that. The bottom line is you may have users issuing what are called high-load SQL statements. Maybe those statements come from your application code and fall on the responsibility of your developers, or maybe some of your business analysts are able to issue ad hoc query against your database, and those queries may not be particularly well written and therefore not particularly well optimized by Oracle. Here's the deal. Data in your data dictionary, data related to your schema objects, your tables, your indexes, all of that stuff, is used by Oracle, a specific component called the Cost-Based Optimizer, or CBO, to figure out how to parse, understand, and process your SQL queries. Now, in this course, we're concentrating on the graphical end. It makes sense because Cloud Control and DB Express give us graphs, and you know that old saying about a picture being worth 1,000 words. Under the hood, you can use PLSQL to get to all of these advisors and frameworks and tuning tools, and you also can go directly into the data dictionary, remember, by accessing the $V dynamic performance views. For instance, User Tab Statistics allows you to take a look at table-level optimizer statistics. Speaking of which, that is one category of optimizer statistic. Table stats look at the number of rows in a table, the number of blocks being consumed in your data file, the average row length. Column by column statistics, the number of distinct values, or the cardinality of data within a column, the minimum and maximum values. I hope your mind is turning. You can see where if Oracle has all of that metadata, it can therefore take a query and be able to generate a fast and efficient execution plan. That's why this is so important. We want our database to be as knowledgeable as possible as to the state of our data over time. And yes, statistics do fall out of date and become stale. Index statistics look at distinct values again, the depth of the index, how many leaf nodes you have, how many branches, etc., how many leaf blocks you have, I should say, clustering factor, etc.